Now here's a fun question. We've got nth term of an arithmetic sequence is un equals natural log of a plus n minus 1 times the natural log of b, where a and b are integers. We want to find a and b. Now we're given the third term is natural log of 16 and the sixth term is the natural log of 128. So how are we going to find out what a and b is? So this is quite a challenging arithmetic sequence question, as arithmetic sequence questions go. So, well, we can see that each of the terms, we've got here ln of 16. So we've got first term, which we don't know. Second term, we don't know. Third term is natural log of 16. Fourth term, we don't know. Fifth term, we don't know. And the sixth term is natural log of 128. Now we know all of these will have a common difference. And what we're given is the common difference is natural log of b. So from here to here to here to here to here, all of these are going to be natural log of b. So that's what we got so far. And what we also know is the first term is natural log of a. So we can put that one in there as our first term. Okay, right. Now, as these are all different, what we could do is we could maybe use this formula with the third term and the sixth term and see where it takes us. So u3, which is the third term, that equals natural log of 16, which will give us natural log of a plus n minus 1. Well, as it's the third term, n minus 1 will be 2. So that's plus 2 natural log of b. Okay, that's our third term. Now the sixth term is natural log of 128. So u6 equals natural log of 128, which will also be natural log of a, that's the first term. And then we're going to add n minus 1, which is 5. And then the natural log of b again, which we know is our difference. Okay, right. Well, we've got two similar things here, even though we don't know what they are. We've got a natural log of b here. So we've got two variables in two equations. So this is going to be just a simultaneous equation. So let's find the difference between these two values here. Now, let's work on the log property here. So log of 16 and log of 128. Well, these are all indices of 2. So log of 16, we can use log property here. So log of, let's say, some value x to the power of y, that is the same as y times natural log of x. So here we've got 16. 16 is the same as 2 to the power of 4. So in terms of log, I can bring that 4 out the front. So log of 2 to the power of 4 is the same as 4 natural log of 2. Same here, 128. 128 equals 2 to the power of 7. So bringing that into our log property, log of 2 to the 7 is the same as 7 log 2. So let's translate these and let's put the biggest one first. So our next line of working will have log of 128, which will be 7 log 2, which we've worked out here. 7 ln 2 equals ln a plus 5 ln b. And then subtract from this one log of 16, which is 4 log 2. So 4 log 2 will give me ln a plus 2 ln b. Okay, right, let's subtract them. 7 minus 4 gives me 3. 3 ln 2's. Subtract those, they disappear. 5 log b minus 2 log b gives me 3 log b. Okay, well, we got 3 log 2 equals 3 log b. So straight away I can see my b equals 2. So b equals 2. Let's write that on here. That's our first solution. B equals 2. Well, if I know b equals 2, I can plug that into one of these equations and solve for a. So if I've got natural log, now let's write this log 16 in the form of 4 log 2. So I've got 4 log 2 equals natural log of a plus 2 natural log, well, I've got log of b, which I know is log of 2. So 4 log 2 equals log of a plus 2 log 2. So let's bring 2 log 2 onto this side. So I've got 2 ln 2 equals natural log of a. Okay, now let's try going reverse for this log property. I can bring that log to 2 to the power of 2. So I've got log of 2, let's just write that different. 2 to the power of 2 equals natural log of a. Well, 2 to the power of 2 is 4, so therefore my a equals 4. So that's an interesting little fun log property question there. Okay.